Hi, I'm Albie. In this video, I cover how to get started with oneAPI for Intel FPGAs using the Intel DevCloud. The Intel DevCloud is a fully functioning development sandbox that gives users full access to Intel hardware and oneAPI. There are Intel FPGAs installed on the DevCloud that you can target to learn more about the data parallel C++ language and how to optimize your code for an FPGA. Once your design is ready, you can deploy it on the FPGA to accelerate your workload. In order to get access to the Intel DevCloud, you must first request it through the Intel DevCloud sign-up page. Once your request is approved, you receive an email with the necessary information to sign in. Before you sign in, you must configure the connection by performing the following steps. Follow the link in the email to the Intel DevCloud landing page. Navigate to Connection Options. Select an appropriate operating system under the Connect with a Terminal. Here, we'll be using Linux to connect. Download your SSH key. Follow the remaining instructions on the page to correctly configure your SSH connection. After this, you should be able to access the Intel DevCloud with a simple command. Once you can log into the Intel DevCloud, you can get started with developing for the FPGA by running some of the provided examples. In this video, I'll be running through a simple vector add example. You can get the vector add design we'll be using from the download location provided in the links. Once you've downloaded the example, you'll need to transfer files to your home directory on the Intel DevCloud using the following command. Once you've successfully transferred them, log into the Intel DevCloud to start running your example. The vector add example comes with a makefile that you can compile in two ways. You can compile to the CPU, also known as emulation, in order to test the functionality of your code and make sure that it's functionally correct. Or you can compile to the FPGA platform to deploy the FPGA bitstream. Here, we're going to be targeting and compiling for FPGA hardware. Make sure you run all the following steps in the directory of the vector add example. To compile your vector add design, you first need to create a job script containing everything that's needed to build the sample. This includes the setup of all the environment variables as well as the actual compile command. This will kick off the full report generation and hardware compile for the design. The output will be an executable that you can run on the FPGA. Note that this process can take several hours, depending on the size and complexity of the design. This command will queue the sample compilation on the Intel DevCloud once you've created the script. The compile job will be placed on a queue and run automatically as soon as a node with the specified property becomes free. The queue subcommand will return immediately. However, the compile job may take longer to complete. In order to use the FPGA on the Intel DevCloud, you must target specific compute nodes that have all the necessary FPGA files installed. When you submit batch jobs using the QSub utility, this label denotes nodes where you can submit compile jobs. Meanwhile, use either of these labels when you want to submit a runtime job to a node. Only these compute nodes meet the requirements for compiling and running the FPGA samples. You can use the PBS nodes utility to see the list of node properties that you can target. You can use the QStat utility to check the status of the job that you submitted. After the job completes, you can view the output file. You can also view any errors that happened while running the job script within the error file. Once the hardware compile job is finished, you need to create a script for running the newly created executable. You also need to initialize the variables in this script before running the sample. Here's the command to submit the job for running the executable. After the job completes, you can inspect the output file to see that it runs successfully on the FPGA. In this demo, we targeted the FPGA hardware. You can also target the FPGA emulator. For more details on how to do that, please see the sample README or the tutorial documentation in the links provided. Now you'll be able to use FPGAs on the Intel DevCloud. To learn more about oneAPI with Intel FPGAs, please sign up for our training, and don't forget to see the links provided for any resources we mentioned in this video. Thanks for watching.
Hey everyone, thanks for watching this video. If you liked it and haven't seen any of our other videos, subscribe to the Intel Software YouTube channel. You can also connect with other developers and enthusiasts in the comments, and we'll see you all next time.